Hello and welcome back to another episode of What's New in SimCenter Star System Plus from engineer to engineer. And welcome Liam to the brand new Hammersmith Studios.
Hi, Rodolfo. Thank you for having me back.
Yeah, so some of you may have noticed that we didn't film the episode for SimCenter Star System Plus 2410. And actually this brand new studio in which we are in now is one of the reasons why the video was not filmed. But we are back. Liam is back with us today. And please, so Liam, Mr. GPU, what will you start with today?
Well, since you've called me Mr. GPU, then I will start with the GPU topic today. And we have a whole bunch of interesting functionalities, both on the hardware and on the physics side, from the 2410 and the 2502 releases that I can talk about. So I'll just go straight into one of the main features, which was the fact that we can now run GPU hardware on Windows operating systems. So we've had GPU accelerated CFD inside SimCenter Star System Plus for the last few years, but that has been limited to Linux operating systems up until now. So in the 2410 release, we have now removed that limitation, and you can run on Windows OSs. In this first release, it's limited to NVIDIA GPUs only, but yeah, you can take full advantage of GPU accelerated CFD on your Windows workstations and on your Windows laptops. So this is really a nice opportunity to significantly boost your workstation performance by leveraging GPU cards that are available to you. And that's the example we are showing right now. So this is a HP Z8 Fury workstation, and this actually has 4 RTX 6000 Ada GPUs inside. And if we take this simulation and run it on the available CPU cores, and then we run it on the available GPU cards, then you can see that it's an incredible 24 times faster by leveraging the GPUs on this system. And this is just a small example of the applications that you could run and the possibilities of taking advantage of hardware on, as I mentioned, your laptop or Windows workstation as well.
Right, I'm sure that a lot of users at home are welcoming this feature, this enhancement a lot, the Windows support. However, we have quite some exciting announcements from the point of view of physics as well.
Yep, that's absolutely correct. So not just the the kind of hardware or operating system expansion, but we've had significant amount of new physics models that are now GPU native inside SimCenter Star System Plus. So if I start with the main two from the 2410 release, then that would be the sliding mesh functionality. So in particular, looking at rigid body motion for any kind of rotating component, such as a car wheel or a mixing vessel or a fan, for example. So that can now run directly on GPU hardware. And another really interesting functionality is the fact that our smooth particle hydrodynamics solver can now be run on GPU hardware. That's been a really nice functionality because that was only fully integrated into Star CCM Plus in 2402, and already we're able to take advantage of GPU hardware only a couple of releases later. Another nice thing about this is that SPH really lends itself very well to GPU acceleration. So you can see one of the examples here. This simulation was run on 64 CPU cores and run on a single A100 GPU, and it's 9 times faster. So that one GPU card is 9 times faster than 64 cores. So really, you get very significant speed up for your SPH simulations using GPU hardware, which is really nice to see. Moving on to 2502. So again, we've added 3 kind of new physics features in this release. The first one being the fact that you can use orthotropic material properties on GPU. The second one being the dual stream heat exchanger, and the third one being solid shells being able to be solved on GPU as well. So you can see, both on the kind of, I'd say the hardware side and on the physics side, we've got a whole bunch of new functionalities that engineers can test.
Indeed, then I like to hear about physics enhancements and so on, but the first question I have is what applications are we enabling with these enhancements?
Yep, that's a really good question. So this release really is unlocking a lot more thermal management applications and really thinking about vehicle thermal management as well. So that dual stream heat exchanger is a key piece for VTM applications, and the orthotropic material properties likewise for battery thermal management, which again is a key application for electric vehicles. If we think about the sliding mesh, then I did allude to wheel rotation. So really having this sliding mesh functionality on GPU really allows you to do full unsteady transient automotive aerodynamics. So effectively that's the full vehicle transient in time with the wheel rotation explicitly modeled, which again is quite important for accurate prediction of the drag.
Right, and what you mentioned is in addition to all the other applications that were already possible in SimCenter StarSim Plus on GPU, do you want to mention some of them?
Yes, so talking about the kind of wide range of applications, I think I mentioned a minute ago that we've had GPU functionality in the in SimCenter StarSim Plus since 2022. So actually basically 3 years since we
Yes.
introduced GPU functionality. And you can see from the chart on the screen that we started with unsteady aerodynamics, but since then there's been a vast expansion in what you can do. So you can do high fidelity scale resolving simulations with large eddy simulation. You can do a full range of conjugate heat transfer applications, both multi-time scale and kind of standard steady state CHT. You can do gas turbine heat transfer and aerodynamics, mixing vessels, high speed aerodynamics now as well, thanks to the real gas equation of state. And then, as I mentioned, moving also towards things like vehicle thermal management, where we can do radiation modeling and other important parts of heat transfer, such as the dual stream heat exchanger that I just mentioned. So really, there's in that 3 years, we've really extended quite significantly the amount of available applications.
Indeed, quite an impressive journey.
Yes.
And Liam, anything else about the GPU?
One extra piece I'd like to add to the puzzle, and that's also the fact that we've talked about hardware and we've talked about physics models, but just to also point out that we continually try to kind of improve the implementation as well. And that can be seen in our 2410 release, where we made algorithmic improvements to the GPU solver, in particular for cases that use the coupled flow and energy model. So again, thinking about heat transfer applications, maybe things like gas turbine heat transfer or aerospace aerodynamics as well. So in 2410, thanks to these algorithmic improvements, we actually see up to 2x performance improvement on GPU. So yeah, we have kind of hardware expansions, we have physics expansions, and we are also, always looking to improve the performance where possible.
Yes, thanks, Liam. So that's an impressive journey. And for the next enhancement, Liam is staying with us, but we connect to a colleague who's connected to us remotely. And let's see, I think, yes, he's ready. And hello, Daniele, how are you today?
Hi, Wolf. Hi, Liam. All good here, thanks. How are you doing?
Yes, we are doing amazing, yes. And you have some adjoint enhancements to discuss today, right?
Yes, indeed. I am very excited to share with you a bit more details on some nice improvements released in SimCenter StarSim Plus 2502, which concern the adjoint solver and specifically the second order discretization for the adjoint solver. In fact, in the past, users may have seen struggles when trying to get a very good convergence with second order adjoint, which means that typical situations where very slow convergence rates or in some extreme cases, even stalling of the adjoint residuals. And in the newly released version 2502, there have been some important algorithmic improvements which overcome these limitations. And therefore, there are a few benefits that I would like to highlight here today. So the first big benefit is, of course, we are going to see a much more stable and robust solution, which also is basically shown by a better convergence rate of the adjoint procedures. And as you may know, typically in adjoint workflows, we do leverage convergence-based stopping criteria, which means that an improved convergence rate also directly translates into saving of turnaround time. And in fact, in many cases, we have seen important speed up of the time to solution for the adjoint solver up to a factor of 3. The second benefit is in terms of accuracy, because in the past, one common workaround to get still a very good converged solution was to revert to first order discretization for the adjoint solver. Of course, compromising a little bit on the accuracy of the sensitivity. And now this will be less needed because, as I just said, good convergence is ensured also with second order adjoint solver, still maintaining the accuracy of the second order discretization.
And from a user perspective, do we have to change any setting in order to take advantage of this enhancement?
No, from the user perspective, there will be no changes needed. In fact, there is no change in the GUI. So you will just need to run a case in the new 2502 version and expect a seamless improved convergence. So it's very easy. For the second contribution of today, I will change a little bit the topic, and I jump into the Lagrangian world of SimCenter StarCCM Plus, because I want to introduce a new type of injector which is released, which is specifically the flat fan nozzle injector. This is a technology which leverages the LISA breakup model, which stands for Linear Instability Sheet Atomization, and is a type of injector which is needed when there is requirement for a flat and uniform distribution of particles that need to be injected, and is really enabling a wide range of industrial applications.
Yeah, I recall having implemented something like this, probably using the table injector for a client who wanted to model spray painting. So what other applications do you have in mind for this enhancement?
Yes, definitely spray painting is one of the main applications for this type of injectors. But the range of applications is very broad, as I said, and you can really think of any process where you have a flat jet impinging over a surface. For example, coating is another one, like any type of surface treatment, or even cleaning of surfaces. Or in some cases, even some cooling technologies might leverage this type of jet or humidification process. So it is technology which is really enabling a lot of new workflows. And yeah, so I think this was my contribution for today. And thanks once again for having me here. It's always nice to participate. And back to you and Liam in the studio in London. Bye. Thank you.
Thank you very much, Daniele. And we are back to the studio, not yet with Liam. Actually, Liam, do you want to introduce the next guest who's presenting an enhancement I really, really love?
Yes, well, that's quite the teaser, Rodolfo. So passing over to my colleague Navid. So I think he's online. Yep.
Yeah, Navid. Hello, Navid.
Hi Rodolfo, hi Liam. I'm glad to hear that you love this new feature, Rodolfo. I'm sure that our users will love it as well. In the new version of StarCCM Plus, we are introducing a fast, pragmatic approach for moving objects called the virtual body method. The virtual body method is a flavor of the immerse boundary method. As you know, Rodolfo, the overset approach that exists in the StarCCM Plus today offers both flexibility and accuracy for modeling moving objects. And it does so by utilizing two separate meshes, a background mesh together with a body fitted mesh. And this way, it ensures the existence of a high-quality mesh near the boundaries of moving objects. And in turn, it produces accurate results. But this accuracy comes at the cost of increased complexity, higher computational cost, and suboptimal scaling. The new virtual body approach that's now available eliminates the need for two separate meshes, and it offers a more cost-effective, easier to set up, and scalable alternative to the overset approach for various validated applications that include pen dipping, bottle filling, industrial machinery applications that involve small gaps such as scroll pumps, plastic mixing, so on and so forth. We have evaluated numerous cases, and for all of these, we have observed very good scalability and speed up compared to the old approaches. Any questions?
Thanks, Navid. Yes, terrific announcement indeed. And I have a question indeed. So, am I right that the virtual body is faster than the overset, but at a price of a lower accuracy?
Well, yes and no. The virtual body method is a versatile technique that offers two distinct ways of setting up a simulation. The first method involves specifying the boundary as the virtual body. This method integrates seamlessly with adaptive mesh refinement to enhance mesh quality near the boundaries of moving objects. At lower refinement levels, this method facilitates generation of quick, low-fidelity CFD results that are valuable in the early design stages, such as conceptual design or preliminary assessments. In the second method, also known as the box approach, a box or a virtual boundary is created around the geometry of interest and designated as the virtual body. And inside this box, then a body-fitted mesh is generated. And thanks to the presence of this body-fitted mesh, the box approach is able to deliver high-fidelity results that are comparable to those of overset method, but at a significantly reduced computational cost.
All right, pretty remarkable.
Thank you, Liam. Thank you, Rodolfo.
Okay, thank you, Navid. And I told you, Liam, that it was a lovely feature, and the more I see it, the more I love it.
Yeah, it's awesome.
And Liam, back to you now about batteries.
Yes, thank you, Rodolfo. So, taking my GPU hat off and putting my Reacting Flows hat back on, I wanted to talk about a few new features focused on battery applications, one that we introduced in 2410 and one that we've introduced in 2502 as well. So just to start with the 2410 feature, then this is an extension to our battery 3D cell designer. So we've had 3D cell design as a functionality for a year since the previous 2310 release. And the idea behind that is to really allow battery cell designers to have, detailed, fully 3D physics-informed understanding of battery cells and how to design them. What we've introduced in this release is aging models. So effectively trying to understand how the battery behaves as it ages. So again, this is quite an important thing to characterize, understand, and ideally design the battery such that the impact of aging can be minimized. If we think about what we have in particular in this release, then we have two new aging mechanisms that account for the mechanical loss of the active materials inside the battery as well. So in particular, these are subgrid particle models. So one is the loss of active material, and the second is the surface crack growth model as well. So you can actually start to understand how cracks can grow within the electrodes of the batteries. And as I mentioned, this is quite a key thing to understand. What's been introduced is actually fairly state of the art, I would say. We've been working with a EU consortium called Modalis, where there's been academic partners and industrial partners to both basically design these models and also implement them inside SimCenter StarCCM Plus and validate them as well. So there's been a lot of effort to kind of introduce these state-of-the-art models.
Right, you mentioned 2 features.
Yes. So the second feature, which has been introduced in 2502, is really allowing you to understand the early cell level thermal runaway of a battery. So in particular, the name of the feature, which is a bit of a mouthful, but it's the Homogeneous Multiphase Complex Chemistry Model. So we can call that HMCC, and another acronym. I know anyone watching this probably loves acronyms with CFD and SimCenter Star CCM+. So yes, the HMCC model is basically a framework that allows you to account for detailed interphase and intraphase reactions so that's basically between a gas, a solid, and a liquid. And these are the type of reactions that can occur inside a battery as it starts to undergo a thermal runaway event. So in this release, 2502, we've basically introduced a framework with our complex chemistry solver. So that's a solver we've had in the software for a long time, very good at stiff reactions, very accurate and very performant. We've basically taken this complex chemistry solver and we've now expanded it into the mixture multiphase model. And basically marrying those components together allows you to start to look at detailed cell level thermal runaway. The nice thing as well about the complex chemistry model is that it means that all of your thermal runaway reactions that you want to capture can be easily imported in the Chemkin format. So that's a fairly standard industry format for reactions and different species. So yeah, it sounds like kind of a lot in terms of a framework, but fundamentally this is allowing you to really start to understand detailed cell level thermal runaway inside battery cells.
Right, so I'm a member of the AAAA, which is the Association Against Acronym Abuse.
Okay.
Since you mentioned a few acronyms, do we have also an example where actually this model has been used?
Yes, and in fact, the example itself is an acronym. This is a ARC test or ARC. But if we park the acronym to one side, fundamentally this test is about putting a battery cell into an oven. You turn the heat up and you start to understand when the battery will undergo thermal runaway. So these tests themselves, are a good way to understand the battery behavior, how it will behave either if it's aged or, starts to overheat. And what you want to avoid is that as the battery overheats, you want to avoid this kind of catastrophic exponential increase in temperature. So that can be extremely dangerous. It can spread to other cells in the battery and ultimately, be high risk of explosions or danger in a vehicle. So really want to avoid thermal runaway as much as possible. Obviously, simulation can play a key role in that and understanding how a battery behaves. So this ARC test, then you basically put the battery in the oven, gradually heat the battery up, and then at some point you'll start to trigger an exothermic reaction inside the battery cell. That exothermic reaction can kind of slowly increase over time, but then you might very suddenly have a thermal runaway event where this reaction takes off. You'll have gas ejection from the battery. You'll have ultimately quite high speed toxic gas being pushed out the battery that can further combust. You can have particles shooting off and things like that. So you really want to avoid this type of behavior. So going back to the HMCC model, then in this example, we basically replicate that test with a simulation. So the really nice thing about this example as well is that we can use all the surrounding functionality of SimCenter Star CCM+ to replicate this test. So like automation features like simulation operations, you can basically really nicely replicate the test. So we simulate heating this battery up, and because we have this chemistry framework, we can now explicitly model all the reactions as they start to take off, and you can really track the behavior of the battery and the kind of the start of this thermal runaway event. And that's what you can see on the plot here. We've really very nicely matched up between the real experimental data and the simulation of SimCenter Star CCM+. So with this ability to do detailed cell level thermal runaway, you can basically understand how the battery behaves and maybe how it will behave inside a wider pack. You could use this as a means to generate heat release that you could put into a pack level model And then you can really design a safe battery system that can either withstand or completely avoid the onset of a thermal runaway situation. So yeah, kind of similar to the previous feature that I just talked about. Again, this has been worked on in conjunction with the SimGeral consortium. So another kind of really nice example of working with academic partners and industrial partners to put, in my opinion, some leading edge kind of battery modeling functionalities into the code.
Very interesting. Thanks, Liam.
No problem.
And now we move to another colleague connected remotely. And yes, there he is. Hello, Andrea.
Hey Rodolfo, hey Liam. Thank you for having me on the show and good to see you in the new office. So finally he's shaping up to be a nice one. So thank you also for having me. I'm very excited to present you today two very different but equally exciting features of SimCenter StarCM Plus 2502. And I'm gonna go right ahead and start with the first one, which has to do with stages. So for those of you who haven't had the chance to test this feature already, or you're not familiar with it, we started this new journey that we call stages in SimCenter StarCM Plus 2310. And it's a feature you can find under the automation node, and you can enable it in your workflow via simulation operation. And it's essentially meant to natively automate very complex workflow that require a change of physics models and solvers throughout the workflow. So the easiest example we can think about is, for example, external aerodynamics, where you want to initialize a solution via steady state run, and then you want to switch to a transient run. So before stages, you could do that via Java. So you could write your own script to do that, and many people have been doing it successfully. But with stages, essentially, you have a new level of native automation that, first of all, removes the need to have separate sim files, and it allows you to do it in a few clicks in a completely seamless way within the same sim file, and leveraging, as I said before, simulation operation. So, as I said, this was first released in a limited with a limited set of functionalities in 2310. But over the release, we've been extending and making this feature of stages more powerful. And this is why SimCenter StarCM Plus 2502 marks a major milestone, because now stages has become really, really powerful when it comes to the amount of solvers that are supported, the amount of options you can do. And we already had some preliminary feedback from our customers, and this is going to be a game changer for native automation. So specifically in SimCenter StarCM Plus 2502, you will have compatibility of basically all the solvers that we have for example, the segregated flow or coupled solver, and essentially unlocking major workflows such as external aero. As I mentioned before, now you have a flexibility to choose any type of solver you want and select it within one or multiple stages. The other major functionality we are unlocking is, for example, for turbomachinery workflows. So you can have a first stage where you run a RANS, Reynolds Averaged Navier-Stokes stage, and then you want to switch to a more advanced harmonic balance simulation. So you can do that with stages now. The third very important functionality that has been enabled with stages in 2502 is also motion, which has been a highly requested feature from our customers that is now available in the release version, and essentially allows customers to switch from a moving reference frame, MRF, to a rigid body motion, which is an extremely common workflow in automotive, again, when you have rotating rims, but all kinds of complex simulations where you have a rotating part where in a certain part of the workflow you want this to be modeled as a moving reference frame, and in a subsequent stage switch to rigid body motion. So this, as it can also be seen in the animation, it's now a few clicks away. So it requires no more complex Javas or no complex debugging or maintaining of scripts. It can be done, as I said, in just a few clicks, and it's totally transparent and controllable via the very intuitive simulation operation workflow. So we are very excited about that, and yeah, we hope our customers will adopt it more and more and enjoy the fact that this removes essentially the stress to rely on complex JavaScripts and do automation natively with very easy features like stages.
I have a question. I'm mainly thinking at a loud voice here, but could I use, for example, stages now to, if I want to initialize the solution using the grid sequencing initialization and the couple solver, and then switch to the segregated solver for a transient run, all automated without Java?
Excellent point, Rodolfo. Yes. So if we, for example, think about advanced external aerodynamics workflow where you would like to leverage the grid sequencing initialization feature that we have in the couple solver of SimCenter RCA Plus, and later on for the transient part of the simulation, you want to switch back to the segregated solver. This is indeed something that is very much possible today with the release of SimCenter RCA Plus 2502. And as you said correctly, there is no need to have any Java. So you are very welcome to talk to our experts or to our application specialists, and they can give you all the details about this. But today I can tell you that such a complex external error workflow can be completely automated without a single line of Java, which is, as I said, for us a major milestone and for our customer a game changer, because it will allow them to spend a lot less time setting up cases and gain this time to actually doing engineering work and optimize the design and take engineering decisions rather than debugging JavaScripts. So pretty excited about that. And so moving on to the other feature I wanted to present today. I'm equally excited about this feature. I've had the pleasure to work on it myself together with our partners at Cordesa LLC. We are now talking about corrosion, completely different topic that than the one I discussed within the context of stages. So, as you know, corrosion is a major problem in across any industry, really, but especially if you think about aerospace and defense, where there is a lot at stake. The hardware and, in general, the machinery one deals with are extremely expensive, both to manufacture, but also in case you have maintenance costs that are required if you have a corrosion problem, then you're talking about potentially millions or hundreds or possibly billions of dollars in costs that you have to assume if a part of your assembly is affected by corrosion. So this is, of course, a field that has been possible to model for a while, and there are solvers out there in SimCenter RCM Plus actually with which you can effectively and accurately simulate corrosion processes. But one crucial point for such simulations is actually the material properties. And for this, we know that there is different solutions out there, but specifically we've partnered with Cordesa, as I mentioned before, who has been a partner for Siemens for a long time, but also is very established in the corrosion simulation market as providing the best-in-class material properties in the form of a material database that it's called Corrosion Gin. So in SimCenter 2502, I'm happy to announce that we have successfully integrated the material database that is provided by Cordesa, that is called, said before, Corrosion Gin. And we've designed an entirely new and very seamless, very easy workflow to set up a corrosion study in SimCenter CM Plus as you did before, but now with the added functionality to call directly the material properties from CorrosionGen into SimCenter CM Plus in a few clicks without having to deal with scripts or exporting tables or any complex, let's say, export import of material properties. Just in a few clicks in the usual solver continuum level, you can bring in whatever material properties you need, couple it with the electrodynamic potential solver, for example, and run your corrosion studies. Once again, this is a game changer for corrosion studies because on one hand, you will have at your fingertips the full power or SimCenter CM Plus with all its benefits of scalability, accuracy, and ease of use for automation. At the same time, you have access natively through the GUI of SimCenter CM Plus to one of the best-in-class material databases for corrosion studies. And with that, essentially, you will be able to speed up your workflows and don't have to deal again with complex import-export process that ultimately will slow you down during your engineering workflow. So with this, I also want to thank our partners at Cordesa, with whom we worked closely for the past 1.5 years. And we are both happy to announce that finally we have this connection and this native functionality within SimCenter CM Plus 2502.
Wonderful. And you may want to mention that in order to use the gene corrosion database, users also need an additional license.
Excellent point, Rodolfo. You're right. So because this has been the result of a partnership between Siemens and Cordesa, in case you want to use the CorrosionGen material database within SimCenter CM Plus, you will need a contract and an additional license from our partners at Cordesa. And this is something that, of course, both the Siemens representative and the Cordesa representative will be very happy to guide you with, to guide you through. And just don't hesitate to contact your usual Siemens support, and we can, as I said, provide you with the right contacts and make sure that you have all the files and all the licenses you need to run coupled simulations with the Cordesa database. So with that, I will leave you to the rest of the agenda that you have for today. And once again, thank you, Liam. Thank you, Rodolfo. Hope to see you soon in the new Hammersmith office. And also looking forward to hear feedback from all the customers out there about SimCenter CM Plus 2502.
And thanks, Andrea, for being with us today.
Bye-bye.
All right, thanks, Andrea. And Liam, back to you with a slight change to the studio layout.
Yes.
Meaning that this is the time for the challenge. And Liam, you're actually competing against yourself today. You own the record, which is 13 features presented in just under 3 minutes.
Yes.
So will Liam manage to do better today? Who knows?
Well, hopefully I can beat myself. But just before we get started, then I think it's always good to ask you, Rodolfo, what your favorite feature was of 2502.
Right. So I already mentioned my love for the virtual body earlier.
Yes.
But there are actually, once again, I forgot to mention it today, but what we are presenting today is just a tiny part of all the new enhancements in SimCenter CM Plus 2502. And there are a lot of them who perhaps don't receive a lot of hype, but they are extremely pervasive in the sense that perhaps every single user will be affected by them. One that I really love So I always compare a lot of sim files.
Yep.
And it was a bit annoying to find in the comparison a lot of differences due to these non-editable fields. Like to see that two sim files were different because the region index was not the same. And I really like this tiny little option that developers implemented in SimCenter StarSim Plus 2502, where you can basically focus the comparison on just on the editable fields to see really what are the difference relevant to the for the user. So it is one of these tiny little features implemented in SimCenter StarSim Plus 2502, which will definitely improve my productivity and my life as a StarSim Plus user.
Good, very good. And I will take a note of that for my attempt.
All right.
Sounds like
So,
something that could be useful to me.
Let's see if you can squeeze that in.
Yes.
And right, Liam, then back to you. Let's
Okay.
start.
Yeah.
And 3, 2, 1, go.
Okay. So what I've done is just opened a new sim file. I'll come back to that in a minute. What I've done in the past, I like to work my way down the tree. So the first one here, I'm in 3D CAD. This is a new feature, the import of streamlines, and I did put some streamlines there as backup. So you can see that's really nice. You can directly import streamlines into 3D CAD. Now I'm just going to do a little bit of background work here. Just get my simulation nicely set up with a few pieces. I've made a block, I've made a region, I made a kind of mesh operation here, and this is going to show two new features. So first of all, volume growth rate can be parameterized, and second of all, you can see the naming convention for multiple parameters has been improved. 1, 2, 3, 4. XY plots. You can see here now we have, you know, a completely new layout of plots, which is really cool. What to do next? Physics. I need physics continua. So okay, let me add a whole bunch of stuff here. It looks like it's chaotic, but I'm thinking here exactly what I need. I need LES. ALF, yep, come back to that. I need Lagrangian for one of the features that may or may not have been mentioned earlier.
Very interesting physics continuum.
Yeah, it's not very sensible, but it all serves a purpose for the most features possible. Now that that's all set up. Field functions, this is a new one. This is field snapshots. So again, you can basically have a quick snapshot of an individual field. Reports, heat transfer report. This can now be idealized, so that's good for turbo machinery, any kind of periodic boundaries. So that's another one. That's a new one. User specified energy source. That's a new field function for any user energy source. I'm going to count that for myself there for pointing it out. ALF, anisotropic lightning propane. That's new turbulent initialization for uniform flow. That's a new feature.
Doing pretty well here.
This is a new query type is inherited part. Yep, that's a new autocomplete. So that one goes in the bag. What next? Okay, yeah, injector. So again, this one was mentioned. This is why I created the Lagrangian Lagrangian phase. If I add this here, then you can see the new flat fan injector. There we go. That's that one added. I don't even know what number I'm on right now. Stages, yep, I'll create a stage, and this is the fact that couple flow can now be stageable. So there we go, there's a stage with couple flow in it. The one you mentioned, let's put that in there, the comparison. So
Wonderful.
come on, there we go. Yep, up on the right, ignore read-only properties. And then final one, GPU for Windows. This is a Windows laptop.
All right.
Yeah,
And we're done.
there you go. I've lost
Liam, I think I counted 13.
So you agree with myself?
I think you matched your previous record.
Yes.
And right. So the Windows support actually is not a new feature of SimCenter StarSim Plus 2502, but it is 2410.
Yeah. I was running out of time. I was hoping you might not notice that one, and so I tried to sneak a bonus.
I didn't notice it, but someone is more careful than me here.
Okay, someone's on the ball. Okay, all right. I hold my hands up. That one.
Not bad. You're in first and second position way.
Okay, well, my performance has regressed by one feature over a few years, but I'll take it.
Good. Well, I think 12 features in under 3 minutes are still extremely good. And again, for the audience at home, one of the reasons why we do this competition is to show actually that what we spoke about is just a tiny part of the enhancements in SimCenter StarSim Plus 2502. And you saw something else in the competition. Liam, I think we are at the end of this video. And before closing, quite a few people that we want to thank, and especially all the developers who work tirelessly to implement all the enhancements that you saw in this release. And without their work, obviously all this wouldn't be possible. Thank you, Liam. Thank you to Daniele, Navid, and Andrea for connecting remotely with us today. And especially thank you very much to all the audience from home, from your office or home office. And see you soon at another episode of What's New in SimCenter StarSim Plus, from engineer to engineer.